we're going to start looking at some parallelograms. A little bit more general than parallelogram is a quadrilateral. So quadrilateral is any polygon with 4 sides. So last framework was all about triangles, 3-sided shapes. Quadrilaterals are 4-sided shapes. So parallelograms are special 4-sided shapes because their sides are parallel. That's why it's called a parallelogram. So there's a bunch of properties that come with it. First, if a quadrilateral is a parallelogram, its opposite sides are congruent. By definition, the opposite sides are parallel, but also the sides have to be congruent. Also, the opposite angles are congruent. The diagonals will bisect each other, and its consecutive angles will be supplementary. So you can actually sum all that up. So here's a parallelogram. By definition, the sides are parallel. By that first theorem that's up there, it says the opposite sides are congruent. So if we know it's a parallelogram, these sides have to be congruent, and these two sides are congruent. Also, the second one says opposite angles are congruent. So that means these two angles will be congruent, and these two angles will be congruent. This bottom theorem right here, while we're talking about angles, says that consecutive angles are supplementary. So not only are opposite angles congruent, but angle 1 and angle 2 right there, those have to add to be 180. And the diagonals bisect each other. So the diagonals are when you draw the lines across from corner to corner. And they bisect each other, which means they cut each other in half. So one side's equal to the other side for each diagonal. There's a whole lot of properties about them. So we're going to start just by doing a proof of one of those theorems we were just talking about, specifically the first one. The opposite sides are congruent. So we're given that it's a parallelogram. So if you're writing a proof, that would be the first thing that you would write down and say, given. And then part of a proof, you can also draw in any line that you want. So we're going to draw in the line DB. It's already done for you there. Just because you can draw lines through any points, it's okay. So AB is parallel to DC, and AD is parallel to BC. We know that because this shape is a parallelogram, and the definition of parallelogram is it's got opposite sides that are parallel. So definition of parallelogram. So since those sides are parallel by definition, if you were to trace the parallelogram, you could get angle ADB, that's this angle here, and CBD. Those are alternate interior angles. Since the sides are parallel, they're going to be congruent. So alternate interior angles. And it's the exact same thing. You just got to draw the other, use the other parallel lines to get ABD and CDB. They're still alternate interior though. So we have these angles are congruent and those angles are congruent. Next, DB is congruent to DB. It's congruent to itself, that's the reflexive property. So when we drew that line, we cut the parallelogram into two triangles. Those triangles are now congruent because of angle, side, angle. We have two angles in the side in between them. Triangle BCD. Actually, let's go triangle ABD congruent to triangle CDB. Doesn't matter how you name them as long as you name it in corresponding order. So the triangles are congruent now. So this ABD and CDB, those are congruent triangles, which means everything about them is congruent. All their corresponding parts are congruent. So AB and CD, those are corresponding parts of those two congruent triangles we just showed. Also, AD, this side, is congruent to BC because those are also corresponding parts of those congruent triangles. So, corresponding parts of congruent triangles are congruent. Also, just a good little visual, you can use rotational symmetry to show that those match up. So if you go back and just look at the parallelogram, you can rotate point C around so that it matches up there with point A, and it would be the exact same shape. It has rotational symmetry of 180 degrees. Everything would match up, so that means that the sides would be congruent just by rotating it 180 degrees. It's a good little visual. So we'll look at another proof. This time we're going to prove that angle A is congruent to angle C. Those are the opposite angles that we were talking about. Opposite angles of a parallelogram are congruent. So angle A is congruent to angle C. That's what we're trying to prove. Those are opposite angles. So we're going to start. We know it's a parallelogram. That was given. You can draw a diagonal. On the previous one, it said through any 2 points, there's exactly one line. So just write something along those lines. Through 2 points, there's one line. So just draw that line. That's all it is. Now, since it's a parallelogram, by definition, the sides are parallel. Definition of parallelogram. Now that the sides are parallel, we can go with some alternate interior angles because we have a lot of parallel lines. We have those parallel lines, so we get angle ADB and CBD. We could also go with the other parallel lines and get these angles here. I wrote ABD first time. ADB, I wrote it the wrong way. Then when we go with the green line that I drew, we have ABD with the other green angle, CDB. So those are both congruent because they are alternate interior angles. So we have this angle is congruent to that one, this one congruent to that one. That's what we just said. Then we get the side in between is congruent because of the reflexive property. That side is BD. You're probably thinking this is a lot like the last proof because it is. Up until this point, it's the exact same. So the two triangles are congruent. Triangle ABD is congruent to triangle CDB. The order doesn't matter as long as you do it in corresponding order. So we proved the triangles were congruent. Now we're trying to prove that angle A is congruent to angle C. They're corresponding parts. Those angles match up. If you rotate this around, C matches up with A. So they are corresponding parts of the triangles, and the triangles are congruent. So angle A is congruent to angle C because they are corresponding parts, and we just said the triangles were congruent. So there's a lot that you could go through and talk about. Since you can easily show that there's two congruent triangles, you can show just about anything you want that's corresponding. You just have to finish it up with CPCTC. So you can get the sides are congruent, you can get the angles, you can do the other angles if you just drew the other diagonal and then did the triangle that way. So this proof's a little bit different because we're talking about the diagonals this time. So you have to draw in both diagonals, which are already drawn in. We're given that it is a parallelogram. That's what we're going to start with. ABCD is a parallelogram. Which means all the sides are parallel. That's the definition of parallelogram. Opposite sides are parallel. So AB is parallel to DC, and AD is parallel to BC. We can make a very similar statement by saying with the opposite sides are congruent, so we do the opposite sides. AD is congruent to BC, and AB is congruent to DC. We've got opposite sides are congruent, opposite angles are congruent, or opposite sides are parallel, which is going to lead to a bunch of alternate interior angles. We can get angle ABD is congruent to angle CDB. We can also get angle ADB is congruent to angle CBD. Since we're trying to get angle side angle, we need this angle up here congruent to this angle down there, which is also alternate interior angles. So it actually trade out what I just wrote in green with this in blue. Doesn't or leave them, just write both of them. BAC is congruent to DCA. Then we have enough to show that this triangle up top here is congruent to the triangle at the bottom by angle, side, angle. So we can go, that's triangle ABE. It's congruent to triangle CDE. So I'm going to free up some of the markings here. We have that triangle on the top is congruent to this triangle down here in the bottom. We just did angle, side, angle, which means these sides are corresponding. So therefore they are congruent. And these sides are corresponding, and they are congruent. So we've got AE congruent to CE. And BE congruent to DE. Which is exactly what we were supposed to be proving.